Hello everyone, welcome back. The learning goal for this video is to use what's called charge balance in order to write the correct formula for an ionic compound. Ionic compounds consist of positive and negative ions or charges held together by strong electrical attractions between oppositely charged ions, and that's called an ionic bond. Once again, this is an example of sodium chloride, which has sodium cations and chlorine anions. Ionic compounds consist of positive and negative ions. They have attractions called ionic bonds that hold them together. Remember, in chemistry, opposites are attracted to each other. As a result of these strong attractions, they have high melting points and are solids at room temperature. Like you saw on the previous slide, for sodium chloride, it is a solid crystalline structure. So sodium chloride is known as table salt, and the magnification of sodium chloride crystals shows the arrangement of the sodium and chloride ions in that crystal. And you can see that they're alternating. Now, sodium and chlorine come from sodium metal and chlorine gas. And we learned in a previous video that metals like sodium lose electrons in order to achieve a noble gas configuration, and nonmetals gain electrons in order to achieve a noble gas configuration. And ionic compounds are formed from a transfer of electrons. So sodium loses its one valence electron to chlorine to make sodium chloride. In a chemical formula, the symbols and subscripts are written in the lowest whole number ratio of atoms. And so what that means is that, for example, let's say my crystal contained 100 sodium cations and 100 chlorine anions. I wouldn't write that the formula is sodium 100, chlorine 100. I'd write it in its simplest formula. It's 100 divided into 100 is 1. So we write the ionic chemical formula as the lowest or simplest whole number ratio of atoms or ions. So 1 and 1. So even though it looks like there's one sodium and one chloride, we understand in table salt, there's a lot more than that. There's lots of sodium cations and lots of chloride anions. It's also critical to note that the sum of the ion charges is equal to 0. That's going to be important when we predict ionic compound formulas. So that means the total positive charge is equal to the total negative charge. For example, sodium loses its electron, it transfers it to chlorine, and therefore we end up with sodium +1 and chlorine -1. So on the outside of the parentheses is the number of atoms, so there's only 1. Inside the parentheses is the charge, so 1 times a +1, plus 1 chlorine times a -1, plus 1 minus 1 is equal to 0. So all your ionic compound formulas, overall charge should always be 0. And you can always double check your work if you're predicting the formula for an ionic compound. Let's look at magnesium chloride. So magnesium has 2 valence electrons. And so if it was going to react with chlorine, it needs 2 chlorines, because chlorine can only accept 1, can only gain 1 electron. So one of them goes to one of the chlorine atoms, and then the other valence electron goes to the other chlorine atom. So if magnesium reacts with chlorine to make an ionic compound, we need 2 chlorines for every 1 magnesium. So it'd be MgCl2. And you can always double check your work. 1 magnesium has a +2 charge, plus 2 chlorines has a -1 charge. +2 minus 2 is equal to 0. So you can always check your work to predict the formulas. And that's going to be a core chemistry skill, is writing these ionic formulas confidently. You can see the same thing here with sodium and sulfur. So each sodium needs to lose 1 electron. Sulfur wants to gain 2 electrons. So it needs 2 sodium atoms in order to gain 2 electrons, so that the overall charge will be 0. Now, the trick to doing this is to do, instead of drawing the atoms themselves and the Lewis symbols, I always teach students what's called the crisscross rule. What I tell them is, first, like if you know you have sodium, predict its charge. So it's in group 1, so +1 charge. And then sulfur is in group 16. What is group 16's charge? Always -2. Good. That's from a previous video. The crisscross rule is you take just the number, don't take the charge, take the number and make it the subscript of the opposite atom. And then here it's a +1, but I'm just going to take 1. And so when you crisscross, you get Na2S1, but we never write the 1. If there's only 1 atom, we just kind of erase that. And once again, subscripts indicate the number of atoms. So you never want to put a charge down there because you're indicating the number of atoms. So this formula for sodium sulfide also indicates that we need 2 sodium atoms for every sulfur in order to balance the charge to make an ionic compound. And the crisscross rule is pretty effective for predicting ionic formulas confidently and efficiently. All right, go ahead, pause the video, try the study check on your own, possibly using my crisscross rule, and then check your work with me when you're done. All right, so we have barium, which is in group 2, so it has a +2 charge, and chlorine, which is in group 17, so -1 charge. Crisscross rule, 1 goes down here, 2 goes down here, so the formula would be BaCl2. And you can always check your work. If you're like still uneasy about the crisscross rule, that's fine. Do the algebra. There's 1 barium. Each barium has the +2 charge. So I always put the charge within the parentheses in my algebra equation. There are 2 chlorines, and each chlorine is a -1 charge. And when I add that up, it is 0. So this is a correct formula. Once again, we never write 1 if there's just 1 barium. We just kind of understand that if we write the symbol, that implies it's 1. And we never put the charge on a subscript because it indicates the number of atoms, and the number of atoms always has to be a positive number. Can't have a negative number of atoms. And there you go. All right, go ahead, pause the video, try this study check on your own, and then check your work with me when you're done. Okay, looks like we have sodium and oxygen already with the charges, which is awesome. So it looks like I need a 2 down here and a 1 down there. So what is your answer? Good, it's B. Once again, you can always double check your work. There's 2 sodiums, each sodium is a +1 charge. There's 1 oxygen, each oxygen's a -2. That works out. Has to add up to 0. What about for number 2, aluminum and chlorine? So the 1 goes down there with the aluminum, the 3 goes with the chlorine, crisscross rule. The answer is A, very good. So you can check your work. 1 aluminum has a +3 charge. This is in group 13. And 3 chlorines have a -1. It adds up to 0. We're good to go. The last one, magnesium and nitrogen, crisscross rule, bring that 3 down here, the 2 down there. And so the answer is C, Good. For 3 magnesium, each has a +2 charge because it's in group 2. 2 nitrogens, each has a -3 charge because it is in group 15, and that adds up to 0. Now, the only caveat to the crisscross rule that you need to be careful for is something like aluminum and nitride, or the nitrogen. If you do the crisscross rule here, you would end up with Al3N3. But remember, when we're reporting ionic formulas, we give the simplest whole number ratio. So if you end up with something like this, where they have the same charge that's greater than 1, then you want to divide to make it the simplest whole number ratio. So this would end up being ALN for aluminum nitride, because you're dividing 3 by 3 and getting the simplest formula. All right, thank you for watching, and as always, email me with any questions.